So today we are going to discuss the 11th chapter of Surgical Audit and Research. I will just read out the chapter for you. Let's see how it goes. So why is this important? It is essential for a surgeon to understand the educational and legal framework in which he or she works. The agenda for medical education and both clinical and research guidelines requires surgeons to expand their skills to encompass audit and clinical research capabilities as useful tools for continued outcome measurements, service improvements, and innovations for benefits of the patient care. The aim of this chapter is to enable improvements in patient experience as a result of a successful audit cycle, and by recognizing the need for clinical research to determine a new or innovative way of treatment. It will also show how to keep track of personal clinical results. In addition, much of the clinical work is tedious and repetitive. Rigorous evaluation of even the most simple techniques and conditions can help keep a surgeon stimulated throughout a long career and ensure good outcomes for patients with cost benefit provider and a benefit to the society as a whole. So you should keep records of all your patients, is what they are trying to say. Rigorous records. A large number of clinical papers appear in surgical literature every year. Many are flawed, and it is important that a surgeon has the skill to examine publications critically. The best way to develop a critical understanding of research and audit undertaken by others is to perform studies of one's own. The hardest part of audit and research is writing it up, and the hardest article to write is the first. The chapter contains information required to write surgical paper and to evaluate the publications of others. How do you write a paper and how you want to evaluate others with is what we are trying to discuss today. The decision will determine the framework in which study is undertaken. In the UK, the Health Research Authority (HRA) has developed a decision tool to help decide whether your project is classified as research. The HRA reflects differentiating clinical audit, service evaluation, research, and usual practice as surveillance. Work in public health is also helpful. You can visit the HR decisions tool at org.uk/research. Audit and service evaluation. Clinical audit is a process by which clinicians who seek to improve patient care. The procedure involves comparing aspects of care like structure, processes, and outcomes against explicit criteria and defined standards. Keeping track of personal outcome data and contributing to a clinical database ensures that a surgeon's own performance is monitored continuously and can be compared with a national data set to ensure compliance with agreed standards. So if you keep data of the patients that you operate for a long term, then you can present it based on the national standard. You can compare it as to how it is based on the national standard. It is also essential component of revalidation for an individual surgeon in UK. If care falls short of criteria chosen, some change in the way that care is organized should be proposed. This may be required at one of the many levels. It might be an individual who needs training or surgical equipment that needs replacing. At times the change may need to take place at the team level. Sometimes the only appropriate action is to change at an institutional level. Regional level, vision of a tertiary referral center, or indeed at national level, screening your life and health education. So if you are good enough, you can, this change can be required at many levels. Essentially, two types of audits may be encountered: national audits and local hospital audits. Both are designed to improve the quality of care. ideal world, national audits should be driven by needs identified in local and hospital-based audits that are closest to the patient. For example, hospital topics are often identified as departmental morbidity and mortality meetings, where issues related to patient care are discussed. The reporting process will identify a possible national issue, and a national audit could be defined to be completed by local audit departments and surgical teams. The Vascular Society of Great Britain and Ireland are working continually with all the members in evaluation of processes and outcomes of major vascular operations. This is driven through Vascular Society Quality Improvement Program, where recently the individual surgeon outcome for elective aortic aneurysm and carotid surgery are recorded. Audits are formal processes that require a structure. Following these steps are essential to establish an audit cycle. How do you form an audit? Formal process that requires a structure. Define the question in a multidisciplinary team. Identify the body of evidence and current standards. Design the audit to measure performance against agreed standards based on strong evidence. Seek appropriate advice. Local audit department to ensure institutions agree to undertake the audit. Meet over an agreed interval. Analyze the result and compare performance against agreed standards. Undertake gap analysis. If standards are reached, re-audit after an agreed interval. If there are need for improvement, identify possible interventions, discuss training and agree with the involved parties, and then do re-audit. Basically, you define a question, what you want to audit, you see what is the current standard for that particular disease or particular care. Then you see how good have you performed, whether it is up to the mark. If it is not, then identify what is the issue. Meet at a certain specific time and place. Discuss about these things. Discuss what went wrong, how to improve. After discussing how to improve, implement whatever we have discussed, and then do a re-audit. Research study. Now, during the design of the audit project, it might become apparent that there is a limited body of evidence available. In this case, the study should be structured as a research proposal. The research is designed to generate new knowledge and might involve testing a new treatment originally. New knowledge and might involve testing new treatment originally. How do you identify a research topic? Once idea has been formed or a question is asked, it needs to be transformed into hypothesis. It is useful to approach surgeons who regularly publish articles and who have a special interest in surgical area reconsider. As ideas are suggested, it is important to consider whether the question posed really matters and to spend some time refining the question, as it probably is the most important part of the process. Choosing the wrong topic at a stage that can lead to many wasted hours. Once a topic has been identified, it is most important not to rush into study. The worst possible outcome is to find at the end of a long arduous study that research has already been done on that chosen methodology did not support investigation of the primary or secondary outcomes. The first port of call for information is the internet, with assistance as needed by the medical librarian. Current articles for the proposed research should be retrieved. Review articles and meta-analysis can be particularly helpful. At this stage, most clinicians go to electronic library and perform a database search. It is important to learn how to do an accurate and efficient search as early as possible. Details are beyond the scope of this chapter, but most librarians will be of assistance. Current techniques involve searching on a Medline or connected database such as Google Scholar, but as electronic information advances, the www World Wide Web becomes more user-friendly. New search strategies may emerge. Collection of reviews are becoming available. The Cochrane collaboration brings together evidence-based medical information and is available in most libraries. Cochrane collaboration is providing evidence-based medical information. Once information on the subject has been obtained, the relevant literature identified, it is important that these are carefully pursued. It is not sufficient to read the abstract of Medline. If proposed project is still looking good after some thorough reading, it is worth further discussion with all colleagues who have written a paper on a similar subject. All scientists are flattered by interest in their work. It is important to ensure the cooperation of any other specialties or clinicians who will be involved in the study to agree on sharing of responsibility for the trial. This will help to prevent disagreements about who takes the credit once study is ready for presentation and publication. It is also helpful to seek support from specific networks set up to support health research. In UK, the National Institute of Health Research Collaboration for Leadership in Applied Health Research and Care works on with partner organizations including NHS, local authorities and universities to conduct applied health research and implement research efforts to improve health and healthcare. There are also a number of training courses and research methodology application. Once the forging has been completed, it should be possible to start plan for your research project. So, how you identify the topic? You transform a question into hypothesis. You do some research as to whether the hypothesis that you are trying to work on, whether any previous papers have been published or previous questions have been asked in the same topic. Then you consult with the other specialty doctors who are also involved and make sure that who takes the credit of publication once the study is over. So once everything is done, you have a good question if you want to do research for the design. How do you design? That's how project is. During the first phase, it is important to keep in mind some important questions to undertake, questions to answer before undertaking research. Why to do such study? Will it answer a useful question? Is it practical? Can it be accomplished in available time with available resources? Will the project benefit from collaboration to increase numbers and make best use of high-tech equipment? What findings are expected? What research governance requirements? What are the ethical issues? What impact it will have? Electronic sites, PubMed Central, Embase, Cochrane. So time spent carefully designing a potential project is never wasted. There are many different types of scientific study. The design used depends on the study. A randomized controlled trial (RCT) is regarded as one of the best methods of scientific research. However, much surgical practice has been advanced through other types of study, such as those listed in For example, testing a new type of operation often requires a pilot study to assess feasibility, which is then followed by a formal RCT. The introduction of innovative surgical techniques may require novel handling and recommendations have been made by ideal collaborators. Research can be qualitative or quantitative. Qualitative research allows hard facts to speak for themselves. Quantitative research allows hard facts to speak for themselves. Medical condition is analyzed systematically using hard objective endpoints such as death or major complications, which should be clearly identified. For example, surgical complications are now classified using Lindo-Kelvin system. In qualitative research, the data often comes from patient narratives. Qualitative is from patient narratives, and the psychosocial impact of disease and its treatment are analyzed. For example, narratives from patients with breast cancer. These kind of data are often collected using quality of life measurements. A variety of different quality of life questionnaires exist to suit several different clinical situations. Much of best research is both quantitative and qualitative. Recently, the importance of outcomes from patients' perspective has been emphasized. Patient-reported outcome measures (PROMs) are now an important component of evaluation of surgical procedures. Patient-reported outcome measures. The research should be focused according to the institutional, national and international strategies. As finances for healthcare are always limited, it is important to consider including a cost-benefit analysis in major areas of research so that the value of proposed intervention or change in treatment can be assessed. The National Institute of Health Research provides a framework through which Department of Health maintains and manages the research staff and research infrastructure of NHS in England. What are the different types of study? Observational, evaluation of a condition or treatment in a defined population. Retrospective, analyzing past events. Prospective is collecting data. Case control, series of patients with a particular disease or condition compared with matched controlled patients. Measurement made on a single location, not looking at the whole population but selecting a small similar group and expanding results. Measurement are taken over a long period of time, not looking at the whole population but selecting a small similar group and expanding results. Experiment. Two or more treatments are compared. Allocation of treatment group is under the control of researcher. Two randomly allocated treatments. Randomized control includes a control group is standard treatment. So once you have a design in place, project design in place, which could be a multiple ways. It can be an observational or case control, cross-sectional or longitudinal or experiment, or randomized control. Now we have to see how big the sample work. Calculating the number of patients required to perform a satisfactory investigation is an important prerequisite to any study. An incorrect sample size is probably the most frequent reason for research being invalid. Often surgical trials are marred by possibility of error caused by inadequate number of patients investigated. So there are two types of errors. Type 1 error, benefit is perceived when really there is none. You will feel that by doing this you will get some benefit, but there is no such benefit. Benefit is missed when it was there to be found. That is called type 2 error. Type 1 error, you feel that there is some benefit, but there is none. Type 2 error, you think there is no benefit, but there was a benefit. Calculating the number of patients required in a study can overcome this bias. Unfortunately, it often reveals that a larger number of patients is needed for study that can possibly be obtained from available resources. This often means expanding enrollment by using a multi-center study. There is no point in embarking on a trial if it will never be possible to recruit an adequate population to answer the research question. More patients will need to be randomized than the final sample size to take into account patients who die, drop out or are lost to follow-up. So if you have reached to a certain sample size, it is always better if you take more patients so that you can count for patients who have either died, dropped out, or are lost to follow-up. Following is an example calculation for a study to recruit patients into two groups. In order to calculate a sample size, it is common practice to set the level of power for study at 80% and with a significance of with a 5% significance limit. This means that there is a difference between study groups. There is an 80% chance of detecting it. Based on the previous study, realistic expectation of differences between groups should be used to calculate the sample size. The formula below uses the figures of reduction in event rates from 30% to 10%. A new treatment expected to reduce complication rates and new nutrition from 30% to 10%. Eliminating bias. It is important to imagine how a study could be invalidated by thinking of things that could go wrong. One way to eliminate any bias inherent in data collection is to have observers or recorders who do not know which treatment has been used, blinded observers. It might also be possible to ensure that the patient is unaware of the treatment allocation. It is in the best randomized studies, neither the patient nor the researcher is aware of which therapy has been used until after the research has finished. So, randomized trials are essentially for testing new drugs. In practice, however, in some surgical trials, randomization may not be possible or ethical. So here you have eliminating bias. How do you eliminate bias? You can blind the observer, whether it could be only the patient who is blinded or the surgeon also is blinded. Now that the question to pose has been decided and it has been checked that sufficient patient should be available to enroll into the study, it is time to prepare the detail of the trial. At this stage, a study protocol should be constructed to define the research strategy. It should contain a paragraph on the background of proposed study, the aims and objectives, a clear methodology, definition of population and sample sizes, and methods of proposed analysis. That this study protocol should be considered to define the research strategy. It should contain what should a study protocol contain. Paragraph on the background of the proposed study, the aims and the objectives, clear methodology, definition of population and sample size, and the method of proposed analysis. It should include the patient numbers, inclusion and exclusion criteria, time scale for work. It is useful to construct the flow diagram, giving clear summary of research protocol and its requirements. Patient numbers, inclusion and exclusion criteria, time scales. It is useful to imagine the paper that will be written about the study before it is performed. This may prevent errors in data collection. When a study is planned, sufficient time should be reserved at the beginning for fundraising, obtaining ethical, regulatory and other approvals. Time for data analysis and preparation of publication needs to be included in funding application. The cost of any non-routine investigation and extra treatments should be given and covered by research grants in the line with national guidance. It is essential to discuss this with institutional leads in advance, well in advance of the grant submission date to ensure appropriate authorization and institution. Data collection form should be designed a computer collection package developed. If data are collected on computer, appropriate safeguards for privacy, confidentiality and data quality will be required to comply with legislation. At this stage, it is important to consider any validation requirements and need for open access either in a recognized archive or in an institutional repository. Any form of data collection needs to be quality assured. The quality assurance process will include training, standard operating procedures, as well as monitoring and checking a certain sample of data. At the end of the data collection and analysis, a final database with all data should be locked and kept for future reference in a safe location. A data archiving policy with a nominated data custodian should be in place. Research is no longer confined by institution or by geographical boundaries. Communication by internet can be a valid way to coordinate international research. The Global Surgical Outcome Collaboration is a group of young surgeons performing collaborative research with internet data collection. Some publishers require registration of a study at the time of study setup on a publicly available database. It is becoming increasingly popular to consider publication of a protocol paper. Regulatory framework. In UK, the implementation of health research governance by Department of Health or its planned successor, UK Policy Framework for Health and Social Care, provides framework that enhances the integrity of study and includes requirements for sponsorship by an institution to ensure the following: peer review, independent ethics review, compliance with data protection, financial probity, dissemination and management of intellectual property. Sponsorship is defined by HRA as the individual, company, institution or organization that takes on ultimate responsibility for initiation, management and or financing of that research. Ultimate responsibility for initiation, management and financing of that research. The sponsor takes primary responsibility for ensuring that the design of study meets appropriate standards and that arrangements are in place to ensure appropriate conduct and report. Once the protocol is finalized, formal peer review is needed. In UK, evidence of peer review will be needed before submitting an application to Research Ethics Committee for an HRA approval. If the research is part of university course, the university, usually the student supervisor, should undertake this review. Surgeons working for NHS can arrange their own peer reviews by experts who are not connected with the study. Alternatively, most research development support units will give guidance through review process. Many funders of research will undertake their own independent peer review. There is usually feedback from this process that can provide valuable advice about the study. In the first instance, common sense is the best guide to whether or not study is ethical. It is still important to seek advice from independent research ethics committee whenever research is contemplated. In UK, the requirement is that NHS Research Ethics Committee provides an independent ethical review of all health and social care research if it involves patients and their carers. The government arrangement for Research Ethics Committee provides detailed guidance about the NHS REC review requirements. The application of NHS REC reviews should be made using an integrated research administration system. IRAS is a single system for applying for permissions and approvals of health and social care and community care research in UK. It enables entry of information about the project once instead of duplicating information in a separate application form. IRS captures the information needed for relevant approvals from the following review bodies: Administration of Radioactive Substances Advisory Committee, Confidentiality Advisory Group, Gene Therapy Advisory Committee, HRA, that is MHRA, etc. Once all relevant forms and associated study documents have been completed, guidance provided by HRA and research ethics should be followed for submission of request for ethical review and HRA approval. If the study does not require review by NHS REC, the need for an independent ethical review should still be considered. Universities have developed their own ethical review infrastructure and will be institute specific and location specific. For collaborative research, local ethical review should be obtained where possible, and developing a local ethics infrastructure should be considered if it does not already exist. Duplication of ethical review should be avoided. Ethics committee prefer to see fully developed trial protocols, but it is often possible to get some preliminary advice from them. The ethics committee forms may seem long and detailed, but it is important that these forms are filled in correctly and it helps to prepare investigation for all practical aspects of the project. All dealings with ethical committees should be intelligent and courteous. It is important to attend the meeting at which the study will be discussed. It is, if invited, as it provides a forum for direct communication in relation to study. It can save times as possible concerns for ethics committee can be addressed at time avoiding lengthy correspondence. In case of interventional clinical or device trials, the European Union Clinical Trial Directive apply, which are regulated by Medicine and Healthcare Products Regulatory Agency. Clinical trials should be registered with European Clinical Trials Database before applying for MHRA. The clinical trial authorization via the Common European Submission Portal. This can be a complicated and tiring process, and support should be sought for investigators and institutions. Editors of major surgical journals are now agree that all clinical trials should have been registered before an article relating to a trial can be published. All the studies undertaken with NHS patients or carers will need a HRA approval, confirmation and capacity with the capability from NHS sites. Studies involving animals require approval from statutory licensing authorities. Reporting on animal research should comply RIN guidelines. Research integrity. The patients and responsibilities. The principles and responsibilities set out in the Singapore Statement on Research Integrity in 2010 was the first international effort to encourage the development of unified policies, guidelines and codes of conduct with long-term goal of fostering greater integrity in research worldwide. The European Code of Conduct followed, and in 2012, universities UK in collaboration with major funders of research developed the Concordat to support research integrity, which sets out key commitments to ensure a high standard in research. All highlights the principles and professional responsibilities of researchers and research institutions that are fundamental to the integrity of research, whatever it is undertaken. He is a center around honesty in all aspects of research, accountability and transparency in the conduct of research, professional courtesy and fairness in working with others, good stewardship of research. A study should not, under any circumstance, commence until the correct approval has been granted in compliance with principle of research integrity is ensured. any challenge to integrity of research can be time-consuming and career-limiting. Statistical analysis. Both audit and research commonly require statistical analysis. Many surgeons find the statistical analysis of a project most difficult part. It is the most commonly criticized part of papers written by clinicians. There are many useful books about statistics that can be consulted. If in doubt, a statistician will be pleased to give assistance. Statisticians like to be consulted before research or audit has been conducted rather than being presented with the data at the end. They often give helpful advice over study design and can be an important part of the project team. The following terms are frequently used when summarizing statistical data. The result of dividing the total number of observations is P. The middle value of equal numbers of observation above and below used numerical or magnitude. The value of highest frequency observed range from the largest to the smallest value. The most important decisions for analysis is whether the distribution of data is normal, is parametric or non-parametric. Normally distributed data have a symmetrical bell-shaped curve and mean, median, mode all lie at the same value. The type of data collected determines whether which statistical test should be used. Numerically or normally distributed. Example, blood pressure. Use unpaired t-test to compare two groups or paired t-test to assess whether a variable has changed between two time points. Numerical but not normally distributed. Example, tumor size. Use Mann-Whitney's U-test to compare two groups or a Wilcoxon-signed rank test to assess whether variable has increased, stayed the same, decreased between two time points. Categorical. Example, admitted or not admitted to intensive care. Can use chi-square test to compare the two groups. So basically, which tests to use when? Numerically and normally distributed between two groups, and paired t-test. Paired t-test, variable that change between two time points. Same person between two time points. Numerically but not normally distributed. Use Mann-Whitney's U-test to compare two groups, or a Wilcoxon-signed rank test. The variable has increased sometimes. Categorical chi-square test. The use of these and any other statistical tests may benefit from the professional advice. Confidence intervals are the best guides to the possible range in which the two differences are likely to lie. A confidence interval that usually includes 0 implies a lack of statistical significance. Confidence interval is the best guide to the possible range in which two differences are likely to lie. Scientists usually employ probability to describe statistical chance. A p-value of less than 0.05 is commonly taken to imply a two difference. It is important not to forget that p is equal to 0.05 simply means there is only a 1 in 20 chance that the differences between the variables would have happened by chance, when in fact there is no real difference. If enough variables are examined in a study, significant differences will occur simply by chance. Trials with multiple endpoints or variables require more sophisticated analysis to determine the significance of individual risk factors. Univariable or multivariable logistic regression analysis techniques may be appropriate. Statistics simply deal with the chance that observation between the particular Statistics simply deal with the chance that observations between populations are different and should be treated with caution. Clinical results should show clear differences. If statistics are required to demonstrate differences between results, it is possible that they are unlikely to have major clinical significance. Computer software package available. Statistical computer packages offer a quick way of analyzing descriptive statistics such as mean, median, range, as well as the most commonly used statistical tests such as chi-square test. Various packages are available commercially and are useful tools in data analysis. Analyzing a scientific article. In the simplest way to analyze an article from a scientific journal is to look at the checklist of requirements of good scientific research. A group of scientists and editors developed the Consolidated Standard of Reporting Trials statement to improve the quality of reporting RCTs. Looking in detail at the study design is often the best way deciding whether a trial is any good. The consort document includes a checklist of conduct of good randomized trials. Often clinicians overlook biases that find obvious to detect, which have a profound influence on the outcome of any study. Even the randomized design does not always guarantee quality, and a core component of systemic review is the grading of trial quality. Several scoring systems have been developed, like Jadad score. Recently, guidelines have been published forming the methods of systemic review and meta-analysis, Prisma guidelines, and also many other types of articles. These can be found in the instructions to authors in most surgical journals, which will now only accept articles that follow the rules. Presenting and publishing an article. There is no point in conducting a research or audit project when leaving the results unreported. Even when results are negative, they are worth distributing. No project, if properly conducted, is worthless. Under reporting of negative outcomes causes a systemic bias in the literature in favor of positive things. Most studies do not provide dramatic results, and few surgeons publish seminal articles. The key to both presentation and publication is to decide on the message and then the aim for an appropriate forum. Big important randomized studies and national audits merit presentation at national meetings and publications in international journals. Small observational studies and audits are often accepted for presentation at regional or hospital meetings for publication in smaller specialist journals. Help and advice from clinicians familiar with the presentation and publication are invaluable at this stage. The most important piece of advice is to follow accurately the instructions for journal submission. Most international meetings will accept presentations eagerly, especially by posters, as these increases the attendance at conference. Most surgeons publish research in peer-reviewed journals. The work that is submitted is checked anonymously by other surgeons before publication. If in doubt about whether to submit to a journal, many editors will give advice about the suitability of an article for submission to their journal. It is usually free to publish in surgical journals since the cost of referring and editing is borne by the journal subscriber. Second model of publication is becoming more prevalent. Open access, author base. This ensures all research is visible to anyone by pushing the costs of editorial processes onto the study budget. It may well become standard in future. Convention dictates that articles are submitted in IMRAD form, introductions, methods, results and discussions. Interestingly, electronic publication and internet may change the face of scientific publication in the next decade. These restrictions on the style may disappear. For now, the IMRAD format remains inviolable. The length of an article is important. A paper should only be as long as the size of the message. Readers of big randomized multi-center trials wish to know as much detail about the study as possible. Reports on small negative trials should be brief. This should always be short. A brief background of the study should be presented and then the aims of the trial and audits outlined. The methodology and study design should be given in detail. It is important to own up to any biases, any techniques or investigations should be detailed in full. If any common practice has been described elsewhere, this should be referenced instead of described. The results are almost always best shown diagrammatically using tables and figures if possible. Results shown in the form of a diagram need not then be duplicated in the text. It is important not to repeat the introduction to reiterate the results in this section. The study should be interpreted intelligently, and any suggestions for further studies or changing the management should be made. It is important not to indulge into fights of fantasy or wild imagination about future possibilities. Most journal editors will delete these things. Recently, a standard format for discussion section has been promoted, and journals such as BMJ are keen that authors use it. This section includes all relevant papers recording previous studies on the subject question. The number should reflect the size of message and importance of work. The reference section does not usually have to be exhaustive, but should include up-to-date articles. Remember to present the references in the style of journal submission. Evidence-based surgery. Surgical practice has now been considered an art. Is to ask 50 surgeons how to manage a patient. You will probably get 50 different answers. There is so much clinical evidence available that no surgeon can know it all. Evidence-based surgery is a move to find best ways of managing patients using clinical evidence from collected studies. It was estimated that sufficient evidence to justify routine myocardial thrombolysis of heart attack was available years before the randomized studies had finally made it clinically acceptable. No one has gathered all available information together. Centers such as Cochrane Collaboration have been collecting randomized trials and reviews to provide up-to-date information for clinicians. The Cochrane Library presently includes a database of systemic reviews, review of surgical effectiveness, and a register of control trials. The BJS has been collecting surgical randomized trials on its website archive for 10 years. There are now almost 1,500 annotated references that can be of valuable resource for scientific authors. As evidence accumulates, it is expected that this will gradually smooth out the differences between clinicians, as the best way to managing patients becoming more obvious. Collecting published evidence together and analyzing it often requires reviews of multiple randomized trials. These meta-analysis involves complex statistical analysis designed to interpret multiple findings and synthesize the results of multiple studies. So this was the chapter on surgical audit and research, chapter 11 of Bain.